So this will focus on Chapter 5, Section 4. And before we get started, your little starting point, what you should be doing first is looking at these 6 problems and figuring out whether the lines are parallel, if they coincide, or intersect at one point. So I want you to take a moment, figure it out, and I'll give you the options. All right, so hopefully you've had a chance to fill these out. If we look here, these two are parallel simply because they both have the same slope. This one here, coincide. And the reason why they coincide is they're exactly the same if you look at it. And that's what coincide really means. If I would double the 2, or I'm sorry, double the x, that'd be 2x. I would double the 3, which is 6y, and double the 9 is 18. These are exactly the same equation. This one here will intersect at one point. When I set them equal to each other, I'll have one ordered pair in which they are both exactly the same. This one here, they coincide. Again, if I go through and I multiply everything by, well, let's look at it. 1/3, I think. Yeah, 1/3. Sorry, 1 and 1/3. So if I take like -6, so -6 times 1.33, it'll go on forever, of course. I'll get my 8. If I multiply the 3 by 1 and 1/3, I'll get 4. And if I multiply the 9 by 1 and 1/3, I get the 12. So they coincide. They're exactly the same equation. This one here, if I look at it, I'll have intersecting at one point. And then finally this one right here, I'll have they are parallel because when I set them equal to each other, and I have y equals mx plus b, the slope will be exactly the same. So can a system of linear equations have no solution? And can a system of equations have many solutions? And that's what we're going to figure out right now through this lesson. So the very first thing we want you to do is take a look at this right here and graph both equations. So I have t and then t plus 3. So basically they'll be the same exact line. It's just one will have a starting point of 3, the other one will have a starting point of t. And if I would graph these out, I'd have my starting point. This is my origin. It's running through the origin. It's going up 1 over 1, up 1 over 1, and so on. This one's starting at 3 and then going up 1 over 1, up 1 over 1. And they will always have a vertical distance of 1, 2, 3 because they're 3 years apart, right? If this person is 3 years older, that's why they'll always be 3 years older than you. Do the graphs ever intersect? They don't because of the fact that they're parallel lines and it will go on forever. I mean, eventually, unfortunately, someone will pass away, but they'll still be the same age from when they were born, right? Like if you would count the amount of years that have elapsed. So they will never cross in this case. So there's really no solution here. Next one I want to talk about is this right here, where I have this system of equations. I have 3x plus 1 and 3x minus 3. And I want to solve it. So I'm going to go through and I'll write this down. I'll have 3x plus 1 equals 3x minus 3. And I draw my line, I box my coefficients. Now here's where the issue is. I want to first move the coefficients to the same side. So I'll subtract 3x from this side. I'll subtract it from this side. But if you look here, I now have 0x plus 1 equals -3. Well, I guess it would be equal 0x minus 3. And if I write this down, I'll have 1 equals -3. That does not make any sense. So in this case, there are no solutions. This is not a true statement. Next one says, try doing this one here. And I have -x plus 3 and -x plus 5. So I'll just go through here, graph them out. So I'll put down my -x plus 3 equals -x plus 5. So I'm going to go through here. I'm going to say plus x on this side, plus x on this side. Now again, I just have 3 equals 5, which again, never happens. It's not true. So there's no solution for this one. This is no solution. This one here will have an ordered pair. Let's just figure out why it has an ordered pair. So I'm going to go through here, and I'm going to do substitution method. So I'm going to have 2, and then instead of having my x, I know that x equals 2y plus 10, and then I'll say plus 3y equals negative 1. So now we'll distribute, right? And I'll have 2 times 2, which is 4y plus 20 plus 3y equals negative 1. I'll combine like terms, and I'll have 7y plus 20 equals negative 1. You'll subtract 20 from both sides, and 7y equals negative 21. So this is really 1 over 7, 1 over 7, and y equals negative 3. Now back to the beginning again. I gotta plug it into one side here, right? And maybe I'll use the equation here, the x equals 2y plus 10, because I know what y equals now. So I'll use a different color, and I'll just say 2 times negative 3, that's what I got for y, right? Plus 10. So this right here is negative 6 plus 10 equals 4. So x equals 4 in this case. And so my order pair would be 4 and negative 3, which is exactly the order pair they have right here. All right, so let's try this problem. It says a perimeter of a rectangle is 36, and I have 2x, so I'd have to do 2x, but I have 2 of those, right? So I'll say times 2, plus I have my 4y, but I have 2 of those as well. And that should all equal 36 units. So I'll put 36. And when I distribute this, I'm going to have 4x plus 8y equals 36. Now I'm going to do the second one real fast. And I'm going to have 6x plus 6y. I'm sorry, 6x plus 6x plus 24y. And that should all equal 108. And when I add this up, I'm going to have 12x plus 24y equals 108. Now, if I want to solve these for each other, I can go through and try to figure out what y equals. So I could do this many different ways. I could try to substitute or eliminate or graph. And what I'm going to do this time is I'm going to try to eliminate. So I want to get rid of, let's say, the x value, right? So I have to take this entire term here and multiply it by 3, right? So I'll multiply this one by, and actually negative 3, because I want to make it equal to negative 12. So I'll say negative 3, and this right here becomes negative 12x. Negative 3 times 8y is negative 24y. And then negative 3 times 36 is equal to negative 108. Oh, wait a second. There's a problem here. Everything gets taken away. I don't have anything left. And that's because these are actually the same equation. It looks different. 4x plus 8y equals 36 and 12x plus 24y equals 108. But they mean exactly the same thing. The important part of this is that all solutions will work. No matter what I plug into this one to make it work, it will work for this one as well because they're the same, right? So in this case, when I subtract these from each other, I will have 0x plus 0y equals 0. And when you have this, it means all solutions do in fact work. So I'll show you this right here. Let me just delete these things. So I could have shown this a couple ways. Number one, I could have graphed it. And if I would have graphed it, it would have been the same line, right? And then if I would solve by elimination, which is what we did here, we'll get 0 equals 0. Well, the point is, it's always true. No matter what you plug in for x and y, it will always equal the same. It will be, these are all answers work. Or infinite solutions, we'll call it. So now let's look at this one here. So in this lesson, just to recap, we've figured out when there's no solutions, and that is when like there's a false statement, like 3 equals 4. It just never happens. And that's when you get rid of the x values, or the y values are just gone. And then we figured out when there's infinite solutions, when you're actually using the exact same equation and finding it or setting it equal to each other. So let's look at this one here. I have x plus y equals 3. And x minus y equals -3, right? So right now, when I set these equal to each other, I will have 2x, this goes away, and this becomes 0. And then x equals 0, and y has to equal 3. So that's my ordered pair. Remember, because if you're dividing, x, or this 2 over 1 by 1/2, and multiply 0 by 1/2, you're going to get 0. So that's this one. Then let's look at this one here. And I'll have 2x plus y equals 5, and 4x plus 2y equals 0. And maybe I want to solve by elimination this time, right? So I'm going to go through, and I'll multiply everything by -2. And when I do this, I'm going to have -4x, I'm going to have -2y, and I'm going to have -10. When I set these equal or figure it out, I'm going to have 0x plus 0y equals -10. Well, this is impossible to do. You can't get -10. You can't. 0 does not equal -10. So this is a no solution. This one here, if I just look at it and I multiply by 6 up here, I'll have 12x, I'll have -12 or -24y, and positive 60. So these will just be the exact same thing, right? So this will have infinite solutions. So far we'll have one solution, no solution, infinite solution. So I have my one solution, my no solution, and my infinite solution. And then here's the last one. And that is the last